Today we're going to talk about the trigonometric ratios. You've been introduced to these in Algebra 2, and we're going to go a little bit further with them and then use them for a whole bunch of things. We spend a long time on trig, so make sure you get these down. Trigonometric ratios deal with right triangles. We're also going to use them for other triangles, but we'll start with their definitions with right triangles. When you have a right triangle, you'll remember that we label the angles with capital letters, and we label the sides across from them with their corresponding lowercase letters. Now, you may recall that there were three trigonometric ratios that you learned last year: sine, cosine, and tangent. And we're taking the sine, cosine, and tangent of an angle. We'll call this one angle theta. That's what the circle with the line is, if you don't remember. And the trigonometric ratios, they're functions. They're doing something to this angle. To say just sine without an angle in it makes no sense. It doesn't do anything. It's just like a log in that respect, that where you have to have something that it's acting on. So sine by itself means nothing, but sine of an angle will give you a number. So, excuse me, sine is the opposite side over the hypotenuse. Remember, these are ratios, so we're taking the ratio of side lengths of the right triangle. Cosine is the adjacent over the hypotenuse, and then tangent is the opposite over the adjacent. You may remember that you learned SOHCAHTOA. The sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So those are all the basic ones that you learned last year. Now we also have some reciprocal ratios that we use. The first one is called the cosecant. And you're going to take that of an angle, and the way you write it is CSC, cosecant of theta, and it's the reciprocal of the sine function. And so that means it's hypotenuse over opposite. Then there's the secant of theta, and you write that SEC, theta, and it's the reciprocal of the cosine. And so that means it's opposite over adjacent. And then there's the cotangent, which is written COT, theta, and it's the reciprocal of tangent of theta, which means it is adjacent over opposite. So you need to know these basic trig functions, and you need to know their reciprocals as well. So we have 6 trig functions that we're going to work with, and in this we're just going to talk some basics about how to find those. So let's look at this. If we're given a point, 8, -6, so this is the point 8, -6. If we draw a ray from the origin to that point, we can find out some information about the angle that forms this ray. And so what we need to do is we need to look at this as a right triangle. Now you'll recall that the first part of the point gives you the x value, so this leg of this triangle is 8, and this leg is 6. Now, because it is below the x-axis, we still need to use that negative. Now, how are we going to find out what the hypotenuse is? Well, there's a couple of ways. We can use Pythagorean theorem. Remember, so a leg squared plus the leg squared equals the hypotenuse squared. So you can do that, or you can remember that there's a special triangle called a 3, 4, 5 triangle, and this is 3 times 2, 4 times 2, so this has to be 5 times 2. So we know that that's 10 because it's a 3, 4, 5 triangle. So now if we want to find all of our ratios, sine, cosine, tangent, cosecant, secant, and cotangent, Then we just use what we know. Opposite over hypotenuse. And then, of course, we can simplify that. And then cosine is adjacent over hypotenuse. So that's 4/5. And the tangent is opposite over adjacent. So that's -3/4. Now, cosecant, remember that's the reciprocal of the sine. You can go back to the triangle and do hypotenuse over opposite, or you can just simply take the reciprocal of the sine. The secant is the reciprocal of the cosine, and the cotangent is the reciprocal of the tangent. And so there we have all 6 trigonometric ratios for this angle formed by the x-axis and a ray that goes to the point 8, -6. Now, what if we're just given a triangle? We're given this triangle here, and we're told that our side lengths are 7 and 9. And we want to know what the trigonometric ratios are for angle A. So that's this one right here. Let's just say we want the sine. Well, we need to find this hypotenuse first. So we use our Pythagorean theorem. And we know that 7 squared is 49, and 9 squared is 81. So we add these together, and we get 130. So that means that C is the square root of 130. Now, we don't need the negative square root because we're talking about lengths, and so we don't have a negative length here. So the hypotenuse is the square root of 130. So the sine of A is just opposite over hypotenuse. Now, I'm going to remind you of something here that is still used in your book, so when they give you the answers, you can see it, but most people don't use it very often anymore. But it's called rationalizing the denominator. Remember, you don't want square roots in the denominator, or at least we didn't used to before we used calculators and just got a decimal approximation. So we multiply by 1 in disguise. So we take the square root of 130 times the square root of 130, which will take that root off, and it just moves it to the top. So when you look for answers in the back of the book, that's what it's doing. If you have a square root in the bottom, they've just rationalized the root so that they don't have a square root in the bottom. It's very old school. People still do that, and you do need to recognize it, but this is fine for me. And you can also just put it in your calculator and get a decimal approximation, but really this is more accurate. So you need to make sure you know all 6 of the trig functions and how to find them off of a triangle or off of the point. Read the section, write down whatever questions you have, and make sure you have some notes to show me.